Oh no. Oh no. A bunch of very different desoldering tools. Let's put these into the ring for our Desoldering Hunger Games. Early last year I made a video looking at the venerable, much loved and much derided ZD915 budget desoldering station, comparing it with the much more expensive but still hobbyist level Hakko FR301. Is this better than this? Yes, well it is. But is it 4 times better? I concluded that episode by saying the cheap and nasty ZD915 was actually stunning value for money and would serve you well if you could put up with 1 or 2 relatively minor niggles, and that the Hakko FR301 was superior in almost every way, most notably not in value. Not confusing at all. So what am I doing back here waggling the same tools at a camera? Well, I've had a year to use the Hakko in some serious repairs, and I thought it would be useful to do a proper roundup of all of the different options if you want to safely desolder components from vintage PCBs. And I mention vintage PCBs clearly here at the outset because that's what I do in this workshop, and my own experiences with these tools will be taken from working on PCBs manufactured 30 or more years ago. If you need to know how these work with more modern boards, this might not be the best video for you, but stick around anyway, as this could be fun. This also won't be an exhaustive look at every model on the market. For instance, the ZD915 comes in many shapes, colours, brands and sizes, but I've assembled a good cross-section of the available tools covering everything from the cheapest all the way up to the Hakko and quite a few in between. Let's have a look at the contenders. Of course, we have my favourite, the Hakko FR301, which is even worse value a year later than it was when I bought it. And the ZD915 returns, but this time it has extra tricks up its sleeves with a few popular modifications to address some of its shortfalls. Sitting somewhere in between those two heavyweights is the Gaojie S-993A, made by the Chinese company Guangzhou Hanghuo Electronics Tools Company, I think. In the comments of the last video, I was heavily recommended the Yihua 948, which at first glance appears to be another ZD915 clone, but as we will discover, this is a whole different unit. And because so many people told me I was stupid for not using a manual solder sucker just like Uncle Albert did during the war,
I fought for free speech. Shut up.
I've decided to put my trusty engineer manual desoldering pump in the ring. And then I went a bit mad and bought these two contraptions because I thought it would be a good idea to cover every budget. Let's get to it then. Before we look at all of these new desoldering stations I've amassed for your entertainment, I want to talk about my year with the Hakko FR301. Is it still as good as I concluded last time? And do I still recommend it despite its high price? Good question. I'm glad you're paying attention. Over this last year, I've used this tool a lot. A lot. And in that time, it has rarely let me down. I did go through a period where it would just lose suction and I couldn't work out why. And it turns out that using a lot of flux to aid desoldering is a pretty bad idea for these tools. Flux will end up working its way past the filters into the pump section, where it makes a sticky mess of flimsy diaphragms. That's a fun word, diaphragms. I know now how to field strip this unit, breaking it down so I can clean out the goop. As well as losing vacuum, I've had a couple of hard blockages, one so bad I destroyed a tip trying to drill it out. The tips on this thing are not cheap. For the record, I find the best way to clear them is to turn the temperature up to its maximum setting, clamp the unit carefully in my bench vise, and then tack a cleaning rod down into the nozzle using a pair of pliers to hold the rod. The biggest annoyance with the Hakko has been the ridiculous power LED indicator on the wrong side of the handle. Far too many times I'm working away for hours on end at my workbench without realising the desoldering gun is still switched on and merrily cooking itself. On one occasion I noticed it was switched on and worked out the last time I'd used it was 2 days prior. Did I mention the tips are not cheap? Still, overall, this tool has done a brilliant job. It heats up very fast, it's easy to clean out the waste tube, and it just chugs along hour after hour without complaint. The other contender from last year was the ZD915. The one I had at the time was a Duratool branded unit, and this one is a generic one. I decided to buy this back just for the purpose of this video from a kind member of my Patreon. It didn't hurt that it was a very good price too. Thank you, Tic Tac. Also, this ZD915 is not your regular off-the-shelf, run-of-the-mill, bog-standard ZD915. Oh no! This ZD915 is a souped-up and modified ZD915. I spent some happy hours upgrading this to make it into a much better tool. If you watch my videos, there's a better than even chance you also watch Jan Beta's channel.
Hi.
My excellent German friend who's been doing this YouTube and retro repair malarkey far longer than most and really knows his stuff. He uses a ZD915 and recently made a couple of videos explaining how to upgrade it to improve its performance. Now, I could have made a video doing much the same thing, but Jan has already done a great job of this on his channel, so if you're curious, you should really go and watch those videos if you want to know all of the gory details. I will leave a link to his channel in the description. But to summarise the modifications I made, let's take a look inside my unit. The two big upgrades in here are the voltage conversion, which was previously done with a couple of beefy resistors, is now taken care of by a cheap, but still nicer than the original setup, buck converter. This takes 18 volts DC from the internal power supply and trims it down to the required 12 volts. The original setup ran the cooling fan off the same supply, and you could hear the fan speed dip as the trigger was pulled, which meant the fan was stealing voltage meant to be going to the pump. I've replaced the fan with a quieter unit and wired it to a dedicated supply on the buck converter where it won't interfere with the power draw. To improve airflow, I chopped a hole in the back of the case and mounted a better quality fan with a nice grill over the top. It's a little noisy and I might slow it down with the resistor, but it's doing a much better job than what this came with. The other upgrade is this beefy relay. The original setup ran the voltage for the pump through a long wire all the way to the trigger in the handset and back again. There would inevitably be some voltage drop, compounded by the fan drawing current from the same circuit. This relay is switched by the trigger in the handle and the voltage is provided to the pump directly from the buck converter at the full 12 volts. The result is a much snappier response and much stronger suction at the moment you pull the trigger. But will this close the gap between this ZD915 and the Hakko? And what about the other contenders? The first and probably the most curious of these is this all-in-one unit. The Gaojie S-993A is available for around £90 to £100 delivered. Do your own currency conversions? From online stores such as AliExpress. My first impression was it seemed to be a hybrid of the ZD915 and the Hakko FR301. That waste collection tube looks very familiar, and being an all-in-one unit makes me wonder if they've straight up copied the Hakko. But the price is way cheaper, so corners must surely have been cut somewhere. Next on the list of desoldering stations is the Yihua 948. I mistakenly assumed this was just another ZD915 clone with a few extra bells and whistles, but it very much is not. Some of its features are a super easy waste emptying method, zero fan noise, and a rather fetching green and black colour scheme. All of the previous options cost a reasonable chunk of money, but do you really need to spend this much on a desoldering tool? There are other options. Let's go right down to the other end of the price scale first and take a look at this Engineer branded pump. This is my one, which I've owned for a few years now. I use this quite often. It works well enough to remove easier stuff like transistors from a ZX Spectrum. And I know of some technicians that use only this to remove all kinds of components from all kinds of boards. I don't possess that kind of skill myself, but I will happily reach for this when I just need to do something simple. The nozzle is made from silicon tubing, which makes it easy to create a seal over the molten joint. This is a point of wear which needs replacing regularly. The pump itself is very well made with a good strong vacuum. It benefits from regular maintenance in order to perform at its peak, but this is pretty easy to do. These can be had for around the £20 mark, but it's also worth noting here that there are now many clones of this tool that might not be up to the job, or they might be. I recently bought this knockoff from AliExpress for just a few pounds, and whilst there are some differences in build quality and construction, this seems to perform really well. Long-term wear might be an issue though. Believe it or not, the Engineer pump is not actually the cheapest desoldering tool on this list. This thing, well, I'm not sure this was the wisest thing I ever did. This is also a Gaojie branded desoldering tool, but this one is at the very other end of the budget scale. I paid £16.99 delivered from Amazon Prime for this thing. The Gaojie 845 comes with a plug that should not be sold in the UK, as it's completely non-compliant with our regulations here. So off with that. No. Inside this suspiciously thin wire are just two conductors, which is another possible cause for concern. In the UK, anything with an external metal case without double insulation requires an earth connection. Not having it here is considered dangerous all by itself. If somehow the live wire became detached inside the unit and touched the metal case, that would then become live. According to the label, this is double insulated, but I'm not sure how much I really trust this. Undeterred, I have fitted a UK mains plug. Best plug in the world, and I will die on that hill. I've also installed a 3-amp fuse to prevent this from electrocuting me too much. Yes, I know the fuse is there to protect the wiring, not me. Just to be double or triply sure, I'm plugging this into an RCD device. Oh, and if this bursts into flames, I have a fire extinguisher handy too. Okay, it's plugged in and switched on. No flames. It seems to be heating up. But before we dig into how well this performs, let's take a look at the last tool on the list. This is another Yihua branded tool, this time a 929D, another manual pump device but with a better brand name. I paid a reasonable £35 for this one. It will be interesting to see if the extra money is worth it. It feels very well made and solid in the hand. It comes with a UK compliant plug, which has a plastic earth pin and the square within a square marking on the label to indicate that this is also double insulated. And I expect some thought has gone into making sure this won't catch fire. Again, more on this device later. Before we fire up these tools and see which one is the ultimate desoldering champion, we need to thank the sponsor of today's video, PCBWay. We all know the dread of using a bad desoldering pump or cheap braid. You apply a little too much heat, pull the component before the solder is fully molten, and suddenly you've ripped a pad or torn a trace clean off the board. It's the classic over-enthusiastic repair nightmare. But when that happens, PCBWay has your back. Instead of trying to bodge a destroyed board with jumper wires and hot glue, if your board has already been reverse engineered, you can order it from PCBWay and have a brand new professional quality replacement board made for just $5 for 10 pieces. And if you're replacing surface mounted chips today, PCBWay can provide custom stainless steel stencils to make putting the new chips back on an absolute breeze. No matter how your repair goes, they've got the fabrication services to fix it. Check out the link in the description below to get your next project started. Now, let's get to testing these tools. Okay, I think 7 Contenders is probably enough. Do I think it will stop someone complaining I didn't include their favourite flavour of desoldering station? No. These cover a good selection of the different options available at most of the hobbyist budget level, and these 7 devices will be put through a series of not exactly scientific tests, which took me literally minutes to devise. The first of which is simply retail price. I'll be comparing prices in my own market as, well, that's where I live, and it would make no sense to convert it when, for instance, the Hakko is much cheaper in other regions. Factor your local prices into your own conclusions. The Hakko FR301, which is by far the most expensive, retailing currently at an eye-watering £420 to £485 here in the UK. As pointed out by many in the previous video's comments, there's also the option of importing a Japanese version and running it off of a step-down converter. This one belongs to my friend Velociraptor Dave from This Week in Retro.
Hello Twirlers, I'm Dave.
He kindly loaned it to me for the purpose of this video. Now, a Japanese-made unit like this one is supposed to run on 100 volts at 60 Hz. And the local supply here is a spicy 240 volts at 50 Hz. The result of using a step-down converter here in the UK is the pump actually runs a little slower than my 240 volt unit. Even though it's running at a higher than usual 110 to 120 volts provided by my step-down converter. So it's getting 10% more voltage, but the pump motor is pulsing at 50 Hz instead of 60. If you're in the US with 110 to 120 volts and 60 Hz, you will need to do a modification to the internals, changing a resistor inside for a couple of other resistors to bring the voltage level down to the correct level. Now, I can't say for sure how safe it is to run the Japanese tool here in the UK using a step-down converter. For one thing, I don't really know what the implication of the higher voltage and lower frequency is with regards to the longevity of the electronics inside this unit. But I can say that my own tests show that the Japanese unit heats up at almost the exact same speed as the UK one, and that the slower pump speed doesn't seem to have a detrimental effect on the suction. I gave it a test on a ZX Spectrum board and it performed perfectly. Having used the Japanese one and testing it side by side with my UK one, I can say for sure that if I was buying one of these units now, I'd be buying the Japanese one and using a step-down converter. Doing it this way will cost a total of around £250, including shipping, duties and a step-down converter. I don't see any downsides to this other than the added step-down unit being a slight inconvenience, and I do recommend this rather than paying out the exorbitant rates being charged here in the UK. It's also worth doing a similar thing if you live in the US, where you won't even need a step-down converter, but you would need to apply the resistor modification. And I don't know where importing will leave you if you need to repair under warranty. But saying that, spares and accessories are extremely expensive. Hakko will sell you spares, but they have a minimum order charge of £250, which costs about the same as ordering a whole new bundle from Japan. The Duratool version of the ZD915 costs a few pennies over £100 from CPC Farnell. There are cheaper clones available that will save you a few pounds, and different versions from other brands. There are also plenty of spares and accessories available for this unit. And let's be honest, you're probably going to need them. This Gaojie S-993A cost me £93.39, satisfying, delivered from AliExpress. I could have spent a few extra pounds and added a spare heating element for when this one inevitably breaks, but I didn't expect to be using this for any great length of time. Availability of spares is still sparse as far as I can tell. The Yihua 948 costs £109.99 from eBay. You can pick this up a bit cheaper from Chinese outlets, but I was impatient. Spares availability should be on a par with the ZD915 units, although the cost of these does seem a bit higher. The second Yihua, the 929D, costs £35 from Amazon. Again, this can be had for much less if you're willing to wait. Extra tips, which you will need, and spare heating elements are all available from AliExpress. And this thing, the other Gaojie. Although the tips might be standard and cheap enough, I'm going to assume that replacing the heating element is probably not financially viable. You might as well just buy a new unit, although I'm not sure why you would buy this twice. As I mentioned before, this cost me £16.99, which I might as well throw down a drain with some petrol and a match. Don't set fire to drains, it's just a metaphor. And to complete the lineup, the Engineer currently costs £20.99. Next category, tips and spare parts. The Hakko is miles out in front with its quick change nozzles, although loses a few points for the price of these. Are we doing points? Is anyone counting? Original Hakko branded nozzles retail for around the £20 mark. I'll let you do your own wincing. There are a huge variety of different tips available for the Hakko, including some long and thin ones that could be handy in very specific situations. All of these other units, right down to the house-burning Gaojie, are screw-on, which is a bugbear of mine. This means you really should wait for the unit to cool down completely to avoid burning yourself. But if you do that, waste solder can solidify behind the tip, which means breaking that seal and possibly your desoldering gun in order to twist it off. The Hakko is the clear winner here in terms of usability, but the ZD915 and the Yihua 948 keep pace because the tips are much cheaper and still of decent quality. The manual pump devices have very cheap feeling nozzles, especially the Gaojie. I can see these not lasting very long at all. The Engineer, as mentioned before, uses a simple silicon tube. Cheap, simple and effective. Category 3, heat up time. Okay, one of the big factors that decide how usable a device is, in my opinion, is how long it takes to be ready. Obviously, the Engineer is the clear winner of this category, being ready in the same amount of time it takes you to pick it up and press the plunger, is almost the entire reason it's still on my bench. The rest require a bit more prep. Let's assume in a normal case they will be ready, plugged in and waiting to be turned on. The key here is how long it takes each one to get to temperature. I have this cheap soldering iron temperature sensor device to give us a good idea of what the temperature is at the tip of each of these irons. My preferred temperature on boards I most often work with is 350 degrees C, but the Yihua is only able to go as low as 380 degrees C, which loses its marks in my personal score. One other thing to note on the Yihua 948 is it will not let you activate the pump until it reaches and settles at its target temperature, which actually takes a lot longer than you might like. The clear winner here is the Hakko FR301, which reached 350 degrees C in a super quick 45 seconds. Not too far behind is its knockoff clone, the Gaojie S-993A, which achieved 350C in a very respectable 72 seconds. Pretty good. Next over the finish line is the Yihua 948, which reached 350C in 135 seconds, but it should be noted that the actual time to be usable is much longer with this unit. I'll get into that later in this video. The venerable donkey in this race, the ZD915, reached 350C in 155 seconds. The two manual pump units were much slower than the much larger and more powerful machines. The Yihua reached 350C in 282 seconds, followed closely by the last placed Gaojie 845 at 302 seconds. Now, it is worth noting here that the two manual pump devices have a much higher working temperature than I would recommend using to work on vintage hardware. The Yihua eventually reached thermal equilibrium at around 410 to 420 degrees C, with the dodgy Gaojie finally topping out at an eye-watering, quite literally if you get too close, 450 degrees C. That is a whole 120 degrees higher than my preferred working temperature.
Thermal equilibrium.
This thing will take off your eyebrows if you're not careful. I'm probably getting a nice tan from this. Thermal equilibrium sounds fancy, but all it means is the heating element, when connected to a mains supply, is capable of a certain amount of energy output in the form of heat. Once the iron reaches a certain temperature, the heat lost outstrips the energy supplied and equilibrium is achieved. As we've already seen, the Yihua 929D reaches just over 400 degrees. This is above what I would consider safe working on ZX Spectrums and Commodore 64s, but on more modern boards, this is actually an ideal temperature. Possibly a bit cool for unleaded solder on a thick multi-layer board. Another concern with the Gaojie at 450 degrees is that at this temperature the cheap tips that come with this thing will just destroy themselves. If it does work in any capacity, it won't do so for very long. I also wonder how safe this is in general. Out of the box it has no fuse, not that I could see, and a direct connection to 240 volts mains. I've only had this running for a short while under testing and I've watched it like a hawk the whole time. I wouldn't feel comfortable plugging it in and leaving it switched on unattended. If it's not already obvious, my recommendation is just don't buy this thing, and if you've bought one, unplug it now, wait for it to cool down and put it in the bin. Okay, that's how long each one takes to reach 350 degrees C, but that's not the whole story. One of these units, the Yihua 948, has a minimum temperature of 380 degrees C. For my own preference, that's a bit on the high side, and over the last few months while I've been using this in repairs, over on my other channel, More Fun Fixing It, link in the description, I clutched the temperature calibration by tweaking the settings so that when the target temp was set to 380 degrees, it would actually be more like 350 degrees. For these tests, I've put the unit back to its stock settings. So how long does it take to reach 380 degrees C, and how long does it take till the unit is actually usable? Let's find out.
3, 2, 1, go.
It's worth pointing out the difference between the display on the tool itself versus the actual temperature as read at the tip of the iron. To begin with, this is wildly out of sync. Towards the end of the test, it starts to catch up. And then there's a pause at the end here where the tool has reached its 380 degrees C target. but I still can't pull the trigger and activate the vacuum pump. 239 seconds later, it's ready to use. Now, this could be seen in two different ways. I could just put this down as a negative and say this is the worst performing in this category of all of the powered vacuum pump machines. And it clearly is the slowest of the more expensive units to be ready. But the other way of looking at this is that Yihua recognised that the most important thing you can do with a desoldering tool to prepare it for use is to make sure it's had plenty of time to reach and soak at its true target temperature. The ZD915 is a notorious tool for blockages, and one of the things that causes this is not being fully up to temperature before use. In this condition, the molten solder is sucked up by the hot tip and then passed through a metal tube into the collection chamber. If that metal tube is cold at one end, the solder will refreeze and eventually block the tube. The Hakko is pretty good for this by throwing large chunks of power into the hot end, but also by having a short stubby tip. So whilst I'm a super impatient person and the Yihua takes an age to heat up, I do appreciate that it works really well when it's ready to use. This is one for you to decide if it fits with how you work. Maintenance and cleaning. Here is me from my previous video demonstrating how quickly the Hakko... Oh, okay, that didn't last very long. The ZD915 I have this time has the newer style quick release. It's still a pain to remove. In the comments of the previous video, I was chided by my friend Julian Brown of the Board Folk, and those Board Folk really should know a thing or two about desoldering, that I was removing the glass tube the wrong way. He said instead of levering it up at the back, it was supposed to be levered out at the front. I'm still sceptical this is correct, as it feels just as hard either way on this unit. It's also much harder to put back as the spring is working against you. It's still fiddly, but it's not the worst one here. It also feels like a good seal, with the rubber at both ends of the glass tube being crushed into place. The Yihua 948 is almost on a par with the Hakko for ease of cleaning. Almost. The capture tube is released by pressing here. The tube lifts easily out of the unit, and then it's just a case of removing the rubber bungs to get to the big spring affair inside. This part had me scratching my head for a while. At first I thought this was an excellent idea, with molten solder being gathered inside this spring to make it easy to remove. But after using it the first couple of times, I thought I'd try cleaning it out and found that the solder welded itself to the base of this spring and was almost impossible to remove. I even resorted to remelting the solder in the narrow end of the spring to aid its removal. Later, after I'd used this a few more times and there was a great deal more solder inside the spring, I realised this was the way to go. With a larger chunk of solder inside, it's easy to wiggle it out in one piece. I was concerned that leaving it full of solder waste would reduce the airflow, but so far that doesn't seem to be the case. And the big benefit here is the solder is much more contained and a lot easier to clear out once you get past having it stuck in the spring. The Gaojie has a similar setup to the Hakko, although the rubber bung holding the filter against the exit tube is not held in the same way as the Hakko. Instead, it seems to be floating around, and I wonder how good that seal is. It's pretty easy to empty though. The engineer pump is a bit more involved, requiring the whole thing to be regularly stripped down and cleaned and lubricated. It's super satisfying to use when it is cleaned though, and taking it apart makes you appreciate how well this thing is made. The other two heated manual solder suckers are a mixed bag. The Yihua has a couple of plastic clips holding the pump section. It's a bit fiddly, but once you get it free, it's pretty simple to clean and clip back into place. Not bad, Yihua. By the way, you should never say the name Yihua with a Geordie accent. The other cheapo Gaojie is, well, it's just bad. The pump section is held in place with a screw. There it is, directly behind the shaft of the pump. To be fair, it's possible to get a very thin screwdriver around at an angle and wangle it out, but that really is a poor design. It won't take long before that screw is stripped. The only question is, will it happen before something else on this thing breaks or catches fire? Once the screw is out, the pump section practically falls off. The only good thing I can say for this is it's pretty easy to clean once you get to this stage, and putting it back together is simple up to the point where you need to put that screw back in. Then it's tricky to the point of being infuriating. The screw is just too long and fouls the back of the metal shaft. It has to be wangled at an angle. Wangled at an angle. Yeah, you heard me. I ended up having to do this with a pair of tweezers. Once the screw is in place, it's a case of hoping you don't cross the threads. Utter garbage. Repairability. I've not yet had to repair any of these desoldering stations, so this won't be an exhaustive category, but in general terms, I can give you an opinion based on what I know about these right now. The Hakko is the one I've the most time with, and the year I've been using it, apart from having to clean it out occasionally, it's never broken. I know anecdotally there can be issues with this part of the plastic casing snapping, which could be a potential weakness in the design. As I mentioned before, spares are available, but the minimum order price makes this a non-starter for anyone wanting to repair their own unit. So the Hakko kind of scores badly here. The Yihua 948 is a very much unknown quantity to me. All I can say is that the availability of spares and the unit appearing to be easily taken apart for maintenance makes this look like a good performer in this regard. Similarly, the ZD915 is reasonably easy to work on and spares are readily available and very cheap. Taking the Gaojie S-993A apart is simple enough and required in order to clean out the pump. As for actually repairing it, well, that will come down to finding spare parts, and currently the only parts I can see available for this unit are the nozzles and the heating elements. The handheld units are all so cheap that repairing them would not really be financially viable. They are consumable in their own right. Okay, on to the next test. Desoldering, the thing you actually bought these things for. In this test I will use this Sacrificial ZX Spectrum Issue 2. These are notoriously hard to work on, and many a budding repairer will have walked away from trying to remove chips on these boards with deep mental scars. They're not impossible by any means, but there are some challenges. For a start, there's no solder mask on the top side of the board. This makes the top traces vulnerable to being pulled up if the chip legs are not completely free of solder. It also means you can have shorts hiding under sockets if you get things a little wrong. Next, the quality of the glue holding the pads onto the board is, well, let's say it's budget. I pride myself in my ability to work on these with a low risk of causing damage, but even so, I've had pads just float away with no obvious reason, which can be quite upsetting, but often it's just down to the poor quality of the materials used. These were very cheap computers, and after all of these years, there are bound to be problems. One of the most prone to failure components on the humble Specky is the lower memory. A row of 8 4116 DRAM 16-pin chips. They require 3 power rails, +5, -5 and +12 volts. If one of these disappears, especially the -5 volts, the internal voltage bias moves wildly out of whack and the chip effectively shorts itself to death. Not ideal. It's not unheard of to find a broken machine with the whole bank of chips gone faulty. We have 7 desoldering tools to test and 8 chips in this bank. For a giggle, I will add to the lineup my very old and not so trusty manual pump alongside the engineer one. This is what technicians used back in the day, and some still swear by them. I've never been able to get used to the timing required to make this effective, but for your entertainment, I'll give it a shot. It'll be fun to see how it stacks up against the others. The board will have a little residual heat from the previous attempts, but I don't think this will make a huge amount of difference. Before each tool is used, I will reflow each pad with fresh leaded solder, which will heat up that area anyway. Then I will give each joint exactly 1 attempt to remove the solder, and then move on to the next one. Okay, here goes nothing. I will start with the old bog standard solder sucker like Grandad used to use. The tip on this is older than some of my socks, and I'm not holding out hope this will do the job well enough. Well, I don't remember ever being good at this type of desoldering, but I don't think I'm doing a terrible job. I will let you lot be the judge of that. One thing about these manual pumps is the solder ends up everywhere. It's making a right mess of my bench. And that's done. At this point, I would normally work on wiggling each leg in its hole in order to free it from any remaining solder, but not today. Oh God. This time I will do the thing I really don't recommend anyone does because it will likely result in damaging the board. I would also normally use hot air on the top side to free the chip, a trick I learned from the brilliant Adrian's Digital Basement, and then lever the chip out. But I'm going to do this part differently, which is admittedly a bit reckless and might upset a few people. I'm going to lever these chips out without heating from the top side. Again, I would never recommend doing this as it will almost certainly guarantee a rip trace or a broken via, and I fully expect this will happen here. But this is a scrap board which has already been pillaged for parts. If I wanted to bring this machine back to life, I would probably transplant the chips into a modern board like this one. Basically, it's my board and it's giving its life to science. I've also seen plenty of videos on YouTube where this is the exact method of removal used, and indeed I've seen it on broadcast TV. But I'm not judging though. What this illustrates is that even with a basic tool, it's possible to remove chips reasonably safely, but I need to highlight any differences in the performance of these tools, so we're going in cold. The result of this half-baked test will most likely depend on the quality of this particular ZX Spectrum board. Some of them seem to be almost indestructible, and some are made of dreams and spun sugar. There are a couple of holes that still look to be blocked, and it looks a little tatty. This could get very messy.
Please forgive me.
You monster, Lee.
Oh, it's just... There it goes. Oh, you are having a... Oh no, I did lose a pad.
Well, to be brutally honest, I was fully expecting the top of that chip to snap off there. So what this shows is that this Spectrum motherboard is one of the more stable ones. Let's see how the other tools fare.
Engineer.
Engineer next. To keep up the theme of the manual pumps first. Again with the reflow. I won't show this again after this time, but it will be done in the same way for all of the other tools. The engineer pump is much easier to use. With the other manual pump, you need to develop a rhythm to get the nozzle into place before the solder freezes. With the engineer, it's a silicone nozzle and you can just jam it into the solder and press the button. It is quite tiring on your hand having to prime the pump over and over, and the solder seems to get caught in the silicone nozzle much more than the plastic one.
Pretty good.
He seems pretty happy with his work. This time all of the holes appear to be mostly clear, but we shall see.
No pads.
Well, that's a surprise even to me. There's going to be an element of luck involved with this, just like there is with everything in life. And a better experiment would be to do this over and over to make a set of results that could stand up to scientific scrutiny. But there are only so many ZX Spectrum motherboards I'm willing to sacrifice in the name of science, and we've already reached my limit. But the way that felt to me taking it out of the board, I was surprised there wasn't more damage. Next is this thing.
Yihua. No, Gaojie. Gaojie 845 SD. Current temperature is 400 and something.
400 and something degrees is plenty hot enough, and it's still climbing. I expect this will be up around 430 to 440 by the time the job is done.
Don't feel comfortable. It's an unbalanced tool.
Like all of the tools on this test, I made sure all of them were cleaned out before starting. The action of the pump is better than it was since clearing out some blockage in the tube. With its very high temperature, it appears to be doing a reasonable job. The solder is being obliterated with heat, and the suction is enough to get the solder out of the board. I don't like this form factor though, it's uncomfortable. My hand is too far from the tip to feel control, but I'm forced to hold it this way as the trigger button is where it is.
Let's get that unplugged before it burns my house down. Oh. Lost one pad again down here. This one seems to be the weak pad. There's a bit of damage up there as well. Not too bad though, and the other side is much more clean than these ones. There's some pad damage, a little tiny bit of pad damage though, probably due to the heat.
After all the chips are removed, I'll put this under the microscope for closer inspection. Onto the manual Yihua 929D.
This one. I'll let this sit for a bit, and it's reached about 420.
420 degrees is pretty hot. I didn't expect it to be this high.
Again, I don't like this. It's uncomfortable.
And this one feels even more unwieldy. Very far from being comfortable.
Yeah, we lost that pad again, I think. Well, there might still be some there. Maybe some damage. We'll have to have a look at that under the scope.
Similar to the others. Let's move on to the next one.
Gaojie. About 370. Which is what it's... No, it's set for 380. But it's coming up as 370. That's fine.
The Gaojie S-993A is by far the noisiest of these tools. It sounds like an angry pygmy cow or a large wasp. Handling wise, it works quite well. Being not too heavy and having a shorter front tube setup makes it feel more controlled. The trigger is responsive and the suction appears to work very well. But did it actually remove enough solder?
That's pretty clean. I think we're going to have issues. Nope, straight out. Oh, hang on. Oh no. Oh no. We've got a trace gone.
To be honest, I thought this would happen much more. So, whilst this seemed to be doing a good job, it wasn't getting the solder from the other side of the board as well as the other tools.
Quite a lot of solder left on this top side. Thank you, Gaojie.
Next is the Yihua 948.
This one, Yihua.
The quietest of the powered pump machines, which not only doesn't have a fan, but also has a very quiet pump. This one is the most comfortable in the hand. It's light and the form factor gives you all of the control you need.
Might be the cleanest so far. Yes.
And taking the chip out, this one came out really easy.
So you can ignore that trace, that was from the previous one. I think. Yeah, lost a pad. Disappointing.
We're all disappointed, Lee. This was meant to be the chosen one.
In case you couldn't guess by the sound, it's the ZD915.
Yeah, this one is really noisy. The fan really needs to be slowed down.
ZD915. 80 watts of desoldering power.
Ready for the original Moo Gun?
Perfect. No lifted pads, no broken traces.
And look at that. The OG Moo did a great job.
Came out very clean. So noisy. Shush.
Last up is the most expensive tool here, the Hakko.
Hakko.
It does feel more bulky in the hand, but it's still very usable. That nice chunky grip works well for me.
Super clean. Oh. Perfect.
And look, the chip almost fell out.
No damage.
Right, let's have a look up close. So the first one on this, I've numbered all of these, so this is number 1. But the numbers are very faint, it's in pencil. And this one is quite a big surprise. There is some damage. There's a bit there. And this pad has gone on the top here. But apart from that, it's not too bad. And you can see how much solder is left in each of the holes. Quite a lot in these 3 here. And there must have been a lot in this one. There's still some in these ones. There's a lot in this one. We were very lucky not to lose that trace and that trace. I think this is just generally down to luck. The next one is the engineer pump. And that's a kind of a similar story. There's a little bit of trace pad damage here. I'm not sure if that's still connected there. It looks like it is. And a little bit there. This is mostly solder. These will probably clean up okay. And there's a little bit there. That didn't lose the pad this time. Some of it's gone. I think these are just a very weak pad. There's nothing connecting it. If there's traces on either side like there are here, then there's a bit more mechanical strength holding this together, but there's no trace connected to this one. So that's always more likely to go than any of the other ones. This one is probably also vulnerable, but didn't seem to suffer. So we've got number 3, which is the Gaojie manual pump, and yeah, we lost that one completely this time. But other than that, they seem to be okay. Still some solder dags there, but not the big lump on the back like there are over on this one here. That's 3. This is 4. This is the Yihua manual pump, and this one looks really clean. There's absolutely no trace damage there at all. This pad, even this pad, is perfectly intact. That's a really good pull. Now we have the Gaojie S-993A, and this is a bit of a disaster. So that trace there came from here, and that's what happens if you don't take all of the solder out. The trace comes up with the leg of the chip. And to be honest, it could have happened on any of these ones prior to this. I'm amazed it didn't actually. There's a little bit of trace damage there as well. That looks like it's on its way. So both of those didn't work. And it looks like most of the solder was removed from these. But only inside the hole, not on this side of the board. It's not a perfect test. This one is the Yihua. And that one also lost a trace here. I'm not sure what to put this one down to. We'll have to look on the other side. Remember, it's on the data line, but there's doesn't look like there's any solder in there. I think this might have been a weak one anyway, so a bit unfortunate for the Yihua, which was one of my favourites going into this. Most of the solder has been removed. Looking at these little dags here, and look, there's nothing in that one. And even the 5-volt line perfectly intact. 7 is the ZD915, and this was a clean pull. There is still some solder in that line there, and some of these, but there's no pad or trace damage at all. And then finally we've got the Hakko FR301, and that is definitely the cleanest of all of them. Look at these holes here, are completely empty. There's no solder in them at all. There's a little bit left in these ones, but not enough to, look, there's just a tiny little bit left there. I can move that away with my tweezers. If I go back to some of these, especially these ones at the beginning, that's too much solder there to move. It's a big lump of solder. Anyway, let's look on the back side. All right, starting with number 1 again. Now we're looking at how much damage the tool does whilst it's heating the pad and extracting the solder. These are quite messy, but the pads are actually not too bad. Look at that one. Basically, that didn't get anything out of that. But not too bad. Better than I thought for the manual pump. This one is the engineer pump. This doesn't look to have done any damage that I can see. No problems at all. Then we've got the Gaojie, horrible 400 and something degrees. That pad there looks like it might be lifting up on this side. Quite a bit of burning as well around. I think we were quite lucky that no damage was done to this, but you can see there's no burning here, but these ones are quite burnt. This is the Yihua, which was also up in the 400 degrees. Again, lots of burnt flux and some pad damage there. Now these look okay, more burning, and no broken pads though. After the Yihua was the Gaojie, I think. Yeah, the Gaojie, which was running at around 370 degrees, so there's no burning. I mean, any burning you see on this side is from this previous desoldering attempt. There's no burning on these ones here, and there's no damage. No damage at all on the pads on this side. And over here, this is the Yihua. No damage at all. All of these look pristine. Tiny little bit of crustiness there, but I don't think that's anything important. And then the ZD915, 0 damage. Looks like that's been very friendly to the pads and to the surrounding areas as well. A little bit of crustiness there. I don't think that's anything. And then the Hakko, lost a bit of solder mask there, but that's, you know, that happens. Not a problem. But look at these pads, they're in absolute pristine condition. You can tell this is the tool I use all of the time. They're barely, I mean, there's a tiny little fold on the edge of that pad. Oh no, that's not a fold, that's just a bit of flux. Yeah, all of those pads are in excellent condition. That's just flux as well. Okay. I would have preferred some more clear-cut results, but I think what I've shown here is that it's possible to damage the board with any of these tools, but that your chances of doing so are increased with some of them. I was half expecting that the Hakko would result in carnage, but was pleased to see it perform as I'd hoped. Any conclusion should be drawn by yourselves, but my own thoughts as the one that was levering out the chips were that the Hakko and the ZD915 did the best job. I was disappointed with the Yihua 948 lifting a trace, and having used that in a few repairs recently, I can say that it does a great job and is in real world use just as good at removing solder as the ZD915 and the Hakko FR301. The manual Yihua performed much better than I expected, but along with the very nasty Gaojie manual pump, ran far too hot for me to be able to recommend either of them for working on vintage PCBs. On a more fragile board, this would have been game over. The old school gold coloured desoldering pump was easier to use than I remembered, but I wouldn't want to rely on this as my main tool. The engineer was very good, and with more care, I think I could reliably remove chips without causing damage using this alone. The Gaojie S-993A it's fine. I don't know, it just doesn't feel like it would be very reliable. I know that's based on nothing concrete, but it makes a huge amount of noise and doesn't actually suck as much solder as some of the manual ones. I worry about its longevity too. It's not cheap enough to be a consideration when stacked up against its closest rivals either. A last thought for you to ponder. That cheap and super nasty Gaojie 845 manual pump was not the worst one on offer. On the same Amazon product page, you can choose another variation made almost entirely of plastic because that worked so well at 450 degrees C. As I mentioned way back near at the start, there are many other variations of these tools out there from a multitude of different manufacturers. I know there's a ZD915 clone that Chrissy of the Board Folks swears by, and everyone seems to have their favourite. But out of all of these, the clear winner for me has to be the ZD915. Wait, what? You heard me. It's cheap, moddable, it does a great job, parts are readily available, and it's nice to use. When modded, it performs just as well as the Hakko in most tasks and costs a good chunk less. But wait, if we just have a think about this for a second, what about that Japanese version of the Hakko? Does the better value make a difference? Well, if you live in the US or Japan, or if you live in the UK and already have a step-down transformer, then yes, the Hakko FR301 is clearly the better tool with its amazing performance, easy cleaning, fast tool change, superb heat up time, and with the Japanese version, great value. But you might be taking a risk with warranty. But I would hope that a tool built to Japanese standards would most likely hold up for the year it would normally be covered for. But that's a risk you will have to take. So to wrap up, my go-to tool, which you will most likely see me using in future videos, is the Yihua 948. Wait, what? You should clear out your hearing, mate. This is purely a me thing and I wouldn't expect anyone else to agree, but the Yihua is just a nice tool to use. It performs really well, I don't need to empty the waste tube nearly as often, and when I do, it's well contained and simple to clean. It feels good in the hand, and best of all, it makes a pleasing burbling sound that's so quiet I can hear the air sucking through the board. On the downside, it takes a lot longer than I would like to heat up and goes to sleep faster than I would like. I believe you can change this in the settings, but those are minor niggles. It's a great tool. In reality, I will probably keep both of these units on the bench and use the Hakko for quick jobs when I'm in a hurry and the Yihua when I have a whole row of chips to desolder. I hope you enjoyed this video and that it proves useful to you in your retro repairs. Don't forget to click the YouTube buttons and maybe join our wonderful Retro Hardware Discord community. If you would like to support my work, a link to Patreon is in the description. I do this full time now and the support I get allows me to make videos just like this one, which cost me much more money than I care to think about. Thank you Patreon members for making this possible. And thank you for watching. I'm on my way to the bin now with this thing. Bye! I'm going to take that plug off first. Garbage!